There's a lot of code to cover today, but I could probably save some time with some copy pasting, copy pasta, as one of my friends says, because I do have a lot of things that kind of overlap. I will be showing you today how to kind of create, well, basically how to write to a file, which I already showed you, replace that file, which I kind of already showed you. It's just writing to that file because it recreates the file with whatever you're writing to it. It's not like it starts the next line or anything. But the important thing that I'm going to be teaching you today, in addition to a logical AND operator and such, is how to get input from a file, how to read stuff from a file, like a configuration file or a stats file. And so the way I'm showing you today, I'm going to be doing my example by making a simple kind of RPG role-playing game type thing. I'm going to be showing you how to have kind of like a leveling system. I'm going to show you a quick kind of slick way to do a loop, kind of a recursive type loop, where you have like while a is greater than 0, system.out.println a equals, or system.out.println plus a, or just a in there. But the thing is, you never subtract 1 for a, so every time it finishes with what it was doing, it starts over at the beginning until you exit. Or run a command like type in, say 6, and choice number 6 is to set a equal to 0, in which case while a is larger than 0 is no longer true, so it moves on to another part of the code. So I'll be showing you that today. Getting a little excited here. So let's just start. We're going to create a file object. Not fine, file. We're going to fine you 500 attack levels. We're going to make a file object called file, very original, of the new file of the name stats.txt. This has to be, this has to be a string in here, a string literal type thing, either in quotes or like, new file A, where A is a string. So the reason that it's getting mad at me about this is because I haven't imported java.io.wildcard, and I'm going to also import java.util.wildcard. File equals that. Forgot an equal sign, and this should be a semicolon, not a colon. And so this is creating our file object of the type stats.txt. We're going to have an integer a that we're going to set equal to 1. That'll be for our recursive loop. We're going to have a boolean. Oh, there's another important thing, checking whether a file exists or not. And if it doesn't exist, creating it. But if it does exist, not creating it, because then it'll overwrite it. Boolean file exists, EXISTS, equals file.exists. And remember, this is just an arbitrary name. I could call it file is there, or lamp, whatever. But then it could get confused with server type things. Anyway, so file.exists is checking for the object file, whether it exists or not. If this was called potato, it would be potato.exists. That is interchangeable with other things. And in fact, we will create another file object later on to kind of re-illustrate the point that you can have multiple file objects of the same file and such. And it would then be f.exists if my object was f, for example. So anyway, we're going to create a scanner object. Scanner user input equals new scanner of the type system.in. Now the reason I didn't use in is because I'm saving in because I'm going to use that for my file writer out, or my print writer out, sorry. My print writer object out, so that way I can do out.println instead of file output.println. It makes it faster for that because I'm going to be using my scanner class less than I'm going to be using my print writer class. So it's good to kind of think of these things ahead of time, or at least go back and change them once you realize the scope of what you're using in your code the most. Actually, we'll be using our scanner class quite a bit. I mean, it'll be used like every time the user does anything, which will be quite often, but it's not a lot of lines of code. There's only a couple times where we're actually getting user input, whereas there's a lot of times where we're writing stuff out to a file. So, for the sake of moving on, we're going to create our random object. Random. That's what happens when I don't say what I'm typing. Random. Random. Maybe my theory is wrong. Equals new random. So that's just creating our random object. Now this is the interesting part. If file exists, the partly interesting part, then try, and I'll explain the logic of this in just a second. File writer out file out file, I'm going to capitalize that, equals new file writer stats.txt. Notice I named this object out file. If I would have done just file, it would get mad at me because that's already been created. That local variable already exists. In fact, I don't think I need this line of code. Let me try doing it without this line of code. That way I can do this. Print writer out equals new print writer file. I'm curious to see if this works. And it does. Okay, so we don't need that extra defining the file object, but you can, in fact. You can if that makes you feel better. You can if that helps you to see what's going on there, but you don't have to. That's a good thing to note. I wasn't sure if that would work or not, so I'm glad it does. So I would do while, or let's see, I'd do an integer, let's say, C. It's like there's so many letters to choose from, right? Then we're going to set the equal to 5, while C is greater than 0. Out.println 1. And we're going to C minus minus each time. So actually, we should make that 4, because we're going to have 4 lines of 1, and then the 5th line is going to be 0, because, oops, I want that outside of there. Out.println 0. And the reason I did that is because we're going to have 5 things that we're storing in the text file. Attack, strength, defense, or attack, defense, strength, constitution. Those are 4 levels. They all start at 1. And battle wins, which starts at 0. So that's why that 0 is there. I could have done it a more roundabout way, of course, if I wanted to. There's probably even a more concise way to do it than that, but it works. We're going to try to catch IO exceptions. Let's just call them E for exception. And if that does happen, we're going to do e.print stack trace. So let Java handle yelling at the user. IO exception, it's singular. That would explain it. Okay, so moving on. Outside of this try catch thing, so right outside of here, we're going to define an integer called count. We're going to set it equal to 0. You'll see why in just a minute what we use that for. We're going to have an integer array. We're going to call it stats, might as well. It's going to be the user's stats, new int, new int 5, not in int. This is helpful because, this is necessary because we're creating, for what I'm doing, an array called stats with 5 placeholders. That's stats subscript 0 through 4. So stats subscript 0, 1, 2, 3, and 4 are all available. Stats subscript 5 does not exist because remember it's 0 through 1 less than that number. Because we include 0, we subtract 1 from that number for how much it would go up to. I explained that in a previous tutorial. I forgot which one it was. If you need to, you can go back and find it. Or if this is the first time you've seen this tutorial, please, there's a link in the description to the first one. If you're a complete Java beginner, please go to that first and just follow them in the order in which they go, Java tutorial 2 after 1 and 3 after 2, in order to get up to speed with what we're doing. If you follow those and pay attention and understand what's in those, it will get you, by the end of Java tutorial 12, up to the point where you can understand what I'm going to do here, I would hope. So we're going to have an integer array called stats. We are going to do another try catch. So we're going to try to do this. We're going to try to create, this is the reading from the file and using that, well, not really using it at this point. Do I use it in this? I use it a little later, yeah. So anyway, it's going to be, I already have this typed up, I've already done this before, I'm just making some minor modifications as I go to stuff that I'd like to change. So try buffered reader in, that's my in object instead of using it for the scanner class, equals new buffered reader, new file reader, stats.text. So we're going to create a string called input, and we're going to say that while input in POW input is equal to in.readLine null parameters is not equal to null, then we wanted to do this. We wanted to define an integer input number, set that equal to integer.parse int. I have gone over this type of stuff. I'm not doing too in-depth of an explanation here because I have gone over parsing integers and such from strings. Input stats subscript count is set equal to input number, and we're going to add one to count. So let me just kind of explain what I did here. So this means I'm going to go way back here. If exclamation mark file exists, that means if the Boolean value of file exists is false. That means false, or is equal to falsified. I don't think that's a word, is it? Oh well. So if the file does not exist, if file exists Boolean is false, so it does not exist, it returns a false value from this line. Then we're going to create a printWriter object out, an integer c, which is equal to 4. We're going to say while c is greater than 0. Then we're going to do this out.println 1, so that we'll have 4, 3, 2, 1. We'll have 4 columns, each with 1s, and then one with a 0. That's going to be attack, strength, defense, constitution. I might do it in a different order, but attack, strength, defense, constitution, and then, but the important part is that this one is a different one. This one's the last one. This one is the battle wins. There is probably I've done this before on this computer too, so in here there's probably a stats.txt. I'm just going to delete that right now. We don't need that. And in fact, I might as well empty my trash. Save an extra 4 kilobytes of disk space, or whatever it was. I forgot, I don't know. I'm not going to bother to do the math on that. So this is, let me do my catch. Okay, so this is, it's printing out 4 1s and then a 0. It's going to try to catch IO exceptions, and if it does, it's going to handle it itself with this line of code. I don't really feel like explaining. Let's see if they offer a good explanation. Prints the throwable and its backtrace to the standard error stream. So it prints a stack trace for this throwable object. So it tells the user basically what went wrong in computer terms. The thing the programmer would look at and say, "Ooh, yay, let's go fix errors." Anyway, you can also put a custom error message in here. I'll show you that later. So buffered reader in equals new buffered reader. We're creating a buffer reader object in. That's a new object of the type buffer reader that depends on file reader for the file stats.txt. That's a confusing line. We're going to define a string called input. We haven't given it any value here, so we're going to give it value here. We're setting input equal to in.readLine. In.readLine is getting the next line from the text file, and every time this runs, it'll read the next line. So it reads all the way out until it gets this \n or \r for returning in or whatever inside of the actual file. We don't have to actually type that there. It's just in there automatically. When we press enter on the keyboard, that's really what's happening. That's really what the text file or the text editor is doing, and when it saves a text file, it includes that thing in it. But anyway, it's going to read the line of text. So it's going to start out with line 0, or line 1, then line 2, line 3, line 4, line 5. It doesn't have a line 0. I don't know how line numbering actually would work in that. I don't know if they'd have a line 0 or not. But anyway, it would read the first 5 lines in systematically and assign that value to input. And while that is not equal to null, it'll do this. When it is, all of a sudden, when in.readLine is equal to null, then boom, you have reached the end. There's no more text, not even enters after that. It's just nothing after that. So in fact, that area those lines have a value of null, in which case we don't really want to put a null value into a, I mean, we have no reason to, in this case, put a null value into a string. So we're just going to do that simple, well, not so simple maybe, but that quick line of code in order to prevent the system from reading in lines that are null and then assigning, stats subscript 5, which doesn't exist, by the way, a value of null, and that does not exist, so that'd probably throw you a bunch of random errors. Well, not random, they make complete sense if you're reading for errors, but they're kind of annoying. Anyway, so we're going to do our catch IO exception, E, and oops, what am I doing? Creating a string out here. E.print stack. Actually, you know what? No. System.out.println. Stop screwing with TIFF files. I'll spell the right. So whether the user screwed with them or not, if it gets an IO exception from reading this, it'll say stop screwing with files. Maybe that should be singular because there's only one file that we're in reference to, and that's stats.txt. For the sake of moving on, I am going to now do my system.out.println. Your attack level is, something else I got to put here is out.close. Out.close. Or else, if I do not do this out.close, it won't actually finalize and write that stuff to the file. It'll just have it temporarily saying, we're going to write this to the file when we do out.close, but we haven't done it yet, so, we got to kind of close that print writer stream type thing so that it actually does write the file. And so, let me just run this real quick and show you. I would like to point out there is no tutorials, there's no stats.txt file there. Now watch that while I run this program. Watch right there. Boom, stats.txt appeared. And so we're going to look at that file. Look, it has our 5 numbers. Now if I delete this, and I take out this out.close, I want you to see what it does. If I run it, so that file is gone, it now appeared blank. So we need that out.close line in order to ensure that that file is given the proper values, that those values are actually written to the file. And so your attack level is plus stats 0 system.out.println. Your defense level is plus stats subscript 1 system.out.println. Your strength level is, I got a talking excited voice. No, stats subscript 2, and then system.out.println. Your constitun level is plus stats 3, and then system.out.println. You have 1 plus stats 4 plus battles. We are also going to have different difficulties of monsters, and so it would really seem unfair to count, beating a legendary monster as the same as beating an easy monster. So in fact, we could do something like you have 1 plus stats 4 plus battle points, and then if they beat a legendary monster, they get X amount of points, and if they beat a hard monster, then they get X over 10 amount of points, and if they beat a medium monster, X out of 100. But I'm not going to worry about that. You can do that yourself. It's a little additional work, and I'm trying to kind of make this a little more concise, but no, that is certainly an option. No as in K-N-O-W, not N-O. And so now we're going to do our wonderful recursive a while loop. While, I don't know if recursive is quite the right word there, but I'm going to use it. So while a is greater than 0, this is going to happen. It's going to do a system.out.println 1 level attack, 2 level defense, 3 level strength, 4 level constitution, 5 level battle, 5 level battle, 6 exit. And exit will not close the application, it'll just simply stop that recursive loop by setting a equal to 0. Or subtracting 1 from a, either one, because a is set equal to 1. I guess we can just set it equal to 0 so that if someone changes the value of a, exit, you don't have to, say if they change it to 10, you don't have to exit 10 times before it really exits, which would be fun. No, it wouldn't. So I'm going to define a double of what to do and set that equal to user input dot next double. Actually, coming to think of it, I think I'm going to use my scanner class way more than I used my buffer reader for in, because I only used that once, but oh well. If I were to do this again, I would probably use a scanner object in and a buffer reader file in, or in file, whatever. Oh well. So if what to do is equal to, or is equal to double equal signs 1, do this. If what to do is equal to 2, do this. I'm doing this so I don't have to count brackets later on in order to figure out what fits